Hello.
Hello.
Yeah. Can you hear me?
Yeah.
Okay. We'll discuss the functions chapter. You've been able to try the questions in the chapter.
Yeah, I did all of them up to 6.6. 16.6, sorry.
16.6, as in the
Like I've
in
done
chapter.
everything I've done everything except the review problems.
What are the problems?
Sorry, what?
What are the questions you were not able to do?
Oh, I didn't need help on any of them. I didn't need.
Uh, if f of x is equal to 3x plus 10, what is the value of x such that f of x is equal to x?
Oh, which question number is that?
Just try, tell me how do you do it.
Oh, okay. Um, there's a value of x such as f. So what you would do, you could put 3x of 3x plus 10 as your x into the 3x plus 10. So then you would get 9x plus 30 plus 10. So that is 9x plus 40, and then make that equal to x, and then just solve the equation.
Hmm. So x is equal to minus 5, right?
Yeah.
Okay, how do you do question number 16.3.3?
16.3.3. Okay. One second.
F of g of x is 3x plus 3, f of x is x plus 6, and g of x is ax plus b. So to find a plus b.
So what I did for this question, I said that wait. Oh yeah. So what I did, I plugged in the gx. So I put x times ax plus b plus 6 is equal to 3x plus 3. Yeah. And so then you get that ax squared plus bx plus 6 is equal to 3x plus 3.
How would you put ax squared?
Because you're putting that ax plus b into the x plus 6, right?
Ax plus b is the input to the f function. If ax plus b is input to the f function, what will f output be?
3x plus 3.
What is the output on the left hand side? 3x plus 3 will use at the end.
Oh, the output on the left-hand side? That would be x times ax plus b plus 6.
Why will it be x times ax plus b plus 6? What is the output
Oh,
when
sorry,
x is the
sorry.
input?
Yeah, the coefficient's 1, sorry. So it'll just be ax plus b plus 6 is equal to 3x plus 3.
What is a and b then?
So then if you bring the 6 to the other side, you get that 3x minus 3 is equal to ax plus b. So then you get a is equal to 3 and b is equal to negative 3. And then if you add those, it's 0.
What is an inverse function?
The inverse function is like a function. So if you put a value x into fx, the inverse of fx will take the output of fx and plug it into the inverse to make it back to the same value.
What do you mean?
Like, so let's say gx is the inverse of fx, and then you plug in, let's say 7 into fx and you get 14. So then if you plug in 14 into gx, you'd get 7. It like reverts it back to its original value.
Okay, have you done the questions in the inverse section?
Yeah.
For example, question number 16.4.3. Question
Wait,
says,
that was a question I needed help on. I must have missed it. But yeah, I did everything else except that one.
for what values of a is fx is equal to x by x minus a, its own inverse. So first of all, we need to find the inverse of this function, and its own inverse means that the inverse of this function is equal to f of x itself, right?
Yeah.
Anytime you have, let's say, let fx inverse be gx. If gx is the inverse of f of x, you should be able to say f of g of x is equal to x, right?
Uh-huh.
Do you understand this?
Yeah, I understood.
Or you can say g of f of x is also x. Because what is happening is f and f inverse x, the two functions are cancelling their effects, then you are getting the same as the input.
Yeah.
Since g of x is the inverse of f of x, this is what is happening, right?
Yeah.
Are you sure you understand these two statements?
Yeah, I understood those two.
So anytime you have function f and its inverse g, either both are true. This is true and this is true. In this problem, the question is saying that gx is actually same as f of x, right?
Mm-hmm.
The inverse of the function is it's the same as the original function.
Yeah.
So obviously that means instead of writing like this, you can write that f of x is equal to x, right?
Mm-hmm.
Then
Yeah.
only the gx is the inverse of itself and it is the same as f of x, right?
Yeah.
So this is the condition for a function to be its own inverse. When you give input f of x to the function, the output is same as x. Right?
Yeah.
So now we have to find for what values of a, and if f of x is x by x minus a, when is f of x going to be same as x? Right?
Mm-hmm.
That is simple. You just calculate what is f of x given this definition. You'll say it is f of x by x minus a, and that should be equal to x by x minus a by x by x minus a minus a. Right?
Yeah.
We are putting, instead of input x, we are putting this thing.
Mm-hmm.
The question is saying that this should be equal to x. So finally we'll have this equation
Yeah.
from which we are supposed to find the value of a. So simplifying this, you will get x by x minus a by x minus a times x minus a by x minus a, where x minus a gets cancelled. And you have x by x minus ax plus a square. And that should be equal to x. So that means x by x 1 minus a plus a square is equal to x. You can try to solve this for values of a that will make that happen. So don't cancel it off and all, just solve it properly. We can say that you get x is equal to x square 1 minus a plus a square x, right?
Yeah.
By cross multiplying, and you bring this term to the other side, you get x into 1 minus a square is equal to x square 1 minus a, right?
Yeah.
And one possibility is a is equal to 1. A is equal to 1 will clearly satisfy both sides are equal, because both sides will become 0.
Yeah.
If a is not equal to 1, you can cancel this factor off, and this will be 1 plus a, and you will get x 1 plus a minus x squared is equal to 0. So x common 1 plus a minus x is equal to 0. But now you're not getting any particular fixed value of a, because a values here will depend on the x, right?
Yeah.
For example, from here we are getting either x is 0 or a is equal to x minus 1.
Mm-hmm. Okay.
But that is not a valid answer, because if you have a function, you cannot always say that only value is x is 0. You can have many different values of x as input.
Yeah.
Similarly, a cannot be a variable. A is a constant, so a cannot depend on x.
Mm-hmm.
So the only way in which this could have happened is the first case where a was 1, in which case both sides were becoming 0, right?
Yeah.
So the function for which this result is true is x by x minus 1. You can see that for x by x minus 1, f of x will be same as x. Right?
Yeah.
You can check it out yourself. X by x minus 1. F of x would be x by x minus 1 minus 1. When you calculate this, x minus x plus 1. So you get a plus 1 here, and x minus 1 will cancel the x minus 1 up and down. It will end up as becoming x only.
Mm-hmm.
So the value of a for which this function is its own inverse is a is equal to 1. Is that
Yeah.
clear?
Mm-hmm.
16.4.4.
For 16.4.4, I said that we can be sure that x is not equal to 2 because 2 is not in the range of g of x.
What is the question?
It's saying that in problem 16.16, we divide 2 minus x. This is only valid if x is not equal to 2. Why can we be sure that x cannot be equal to 2?
So explain what you're doing, what you're saying.
Okay, so basically, I was saying in the solution to find the inverse of the function g, they divided by 2 minus x on one of the steps. And the reason that this is possible and how we know that x is not equal to 2 is because 2 is not in the range of gx. Because, see, if the output of gx will be plugged into the function f, but if that output is not a possible range of the function, then it can't be inputted into the inverse. And you can test it out. If you say that 2 is equal to 2x minus 3 over x plus 5, and then you solve it, you'll get that 2x plus 10 is equal to 2x minus 3, which is not possible. So that's why we know that 2 is not in the range of gx.
How do you find the inverse here? Suppose f we have to find which is the inverse of g. How do you find it?
So we could just say that both of them are inverses of each other. So you could also say that g of f of x is equal to x. So then you could plug in f of x into function g to get 2f of x minus 3 over f of x plus 5 is equal to x. And then what you can do, you take it,
Solve for f.
yeah, and then you cross multiply to get 2f of x minus 3 is equal to x fx plus 5x. And then what you do, you like use distributive proper, yeah.
F of x is coming as 5x plus 3 by 2 minus x.
Mm-hmm.
And then you can find f of 4.
Yeah.
The point is, in order to find the inverse, you have to either use g f of x equals x or f g of x equals x.
Yeah.
These two results should help you find the two functions. So if the function is inverse of itself, then you will get, instead of g, you will get f of x equals x.
Yeah.
If f and g are same. Then the next set of questions is 16.5, that section.
Mm-hmm.
How do you do 16.5.1?
5.1. Okay.
G of 2x plus 5 is equal to 4x square minus 3x plus 2.
Mm-hmm.
You have to find g of minus 3. Did you try this before?
Yeah, I did, but I think I might have made a mistake in my work now that I'm looking at it.
We have to find the function g, then only we can find this, right?
Yeah.
The input to the g function is 2x plus 5. So you have to think of like how can you manipulate 2x plus 5 to get this, right?
Mm-hmm.
If you are able to say that, suppose you had an equation like this, g of x plus 1 is equal to x plus 1 whole square minus 1. Can you figure out what is g of x then?
Yeah.
What is g of x here?
G of x is equal to x minus, wait,
If g of x plus 1 is equal to x plus 1 whole square minus 1, what is g of x?
G of x is x squared minus 1.
Exactly. The way you are able to say that is because when you put input x plus 1, you are getting in terms of that input something here, right?
Yeah.
So what we have to see here is, can I write g of 2x plus 5 as something in terms of 2x plus 5 and stuff with it, right?
Mm-hmm.
It is obvious that this is a quadratic and this is a linear thing. You should have something like 2x plus 5 whole square here,
Yeah.
because then only you will get a square term. You take 2x plus 5 whole square, you'll get 4x square plus 20x plus 25. But what do you have here? You have a minus 3x and a plus 2, right?
Mm-hmm.
Okay, so think about what can you subtract to get a minus 3x? You have to subtract minus 23x.
Yeah.
So let's subtract a minus 12 times 2x plus 5. Right, so you are subtracting total what? Minus 24x, right?
Mm-hmm.
Okay, let's not do that. Let's just do 23x. So in order to subtract minus 23x, you will have to say 23 by 2, right?
Yeah.
So what are we getting? When you combine this and this, you are actually getting the first two terms, right?
Mm-hmm.
Because you're getting minus 23x and minus 23 into 5 by 2, correct?
Mm-hmm.
So see that it is becoming 4x square minus 3x at least. Only the constant term so far is not correct.
Uh-huh.
Do you understand what I'm saying?
Yeah.
The constant term is not correct, so we'll just add a whatever appropriate constant. We need to have a plus 2 at the end. We have right now 25 minus this thing, right?
Yeah.
So 25 minus 115 by 2 is actually going to be 50 minus 115 by 2, so 6 minus 65 by 2 we have. And we need to get a plus 6 plus 4 by 2 we need. So we'll add a plus 69 by 2, right? Plus 69 by 2, right?
Yeah.
If you do this, what am I trying to do? I'm trying to write this thing in terms of 2x plus 5.
Correct.
I'm getting 2x plus 5 whole square minus 23 by 2 times 2x plus 5 plus 69 by 2. That is equal to g of 2x plus 5. If you simplify this whole thing, you will end up getting 4x square minus 3x plus 2.
Yeah.
Is it clear why?
Yeah.
So now if I know g of 2x plus 5 is looking like this, it is very easy to say what gx is.
Mm-hmm.
What is gx?
Gx is x squared minus 23 over 2x plus 69 by 2.
Right. Plus 69 by 2. And therefore g of minus 3 would be 9 minus 23 over 2 into minus 3 plus 69 by 2. And this becomes plus 69 by 2 plus 69 by 2. So it becomes 9 plus 69, which is 78. Right?
Yeah.
G of minus 3 is coming out to be 78 for us. Because we have actually found our g of x. How did I find my g of x? By trying to write this function g of 2x plus 5 in terms of 2x plus 5 as a variable, right?
Right.
Obviously 2x plus 5 is linear and this side was a quadratic, so I have to do square and stuff. Square and later subtract and add whatever to adjust it to become equal to this, right?
Right.
So we are getting 78 as the answer. Another way to do this question would have been just that instead of trying to find g of x, you can just try to get the answer g of minus 3 by realizing that I already know what is g of 2x plus 5, 4x square minus 3x plus 2. I don't care about what gx is, I need g of minus 3. So from here it should be obvious what is the value of x you need to take to make it minus 3, right?
Yeah.
If 2x plus 5 is minus 3, 2x is equal to minus 8 and x is equal to minus 4.
Oh, yeah. I think that's what I did. But then I think my answer came out different because I got 54. I must have made a calculation mistake.
If you put x is equal to minus 4 on both sides, you will get g of minus 3 is 4 into minus 4 square 16 minus 3 into minus 4 plus 2. This is 64 plus 12 plus 2, which is 64 plus 14, which is 78.
Yeah, I think I did minus 12 by accident.
There are both methods. One method is this. This is easy in this case because 2x plus 5 is equal to minus 3 is directly giving us what is the x.
Mm-hmm.
But in general, you should also be able to find g of x the way we found g of x here.
Yeah.
What happened in 16.5.2?
5.2. For part A,
Explain the question first. What is the question and what you have done?
okay. So the question is, sorry. Alice and Bob go for a run in the local park. Alice runs at 3 meters per second. Bob starts from the same point as Alice, but he starts 20 seconds after Alice. Bob runs at a rate of 5 meters per second. For A, it says, let T be the number of seconds that have elapsed since Bob started running. Find functions describing Alice's and Bob's distance in meters from Bob's starting position in terms of T. So what I got is that Bob is 5T because he runs 5 meters per second and T is the amount of seconds that has done it since he started. And then I got Alice is 3t plus wait. Three T plus 60.
Alice has been running for 20 more seconds.
Yeah, so 3T plus 60.
Okay, what is the next part B?
How many seconds after Bob starts running has he run 50% farther than Alice? So if he runs 50% farther, I multiplied 1.5 times 3T plus 20, and I made that equal to 5T. Yeah, and then I just solved that equation to get that 60 is equal to T.
Okay, T is 180, no? If you multiply 1.5 of this, what are you getting? 4.5 plus 90, right?
Oh, I wrote 3T plus 20 in my answers. Oh, okay. But then if you do it with 60, then 4. Yeah, then it's 180.
Take T as 180 seconds. The distance Bob has run is 5 times 180 or 900 meters. And the distance Alice has run is 200 into 3, which is 600 meters.
Yeah.
900 is 1.5 of 600. Do you understand?
Mm-hmm.
16.5.3.
16.5.3. Okay.
F of 2x is equal to 2 by 2 plus x for all x greater than 0. You have to find out what is 2 times f of x.
So what I did, I plugged in f is f of 2 times x over 2 is equal to 2 over 2 plus x over 2. And then I solve that to get fx is equal to 4 over 4 plus x, which then if you multiply that by 2, you get that 2f of x is equal to 8 over 4 plus x.
So you are replacing x with x by 2, right?
Yeah.
If you replace x with x by 2, you will end up getting the function f of x. Right?
Yeah.
This is what your f of x is.
Mm-hmm.
So twice of f of x becomes 8 by 4 plus x.
Yeah.
Okay. 16.5.4.
5.4. Oh. Let Pn and Sn denote the product and the sum, respectively, of the digits of the integer n. For example, P of 23 equals 6 and S of 23 equals 5. Suppose n is a two-digit number such that n equals Pn plus Sn. What is the units digit of n? Okay, so what I did, I labeled the tens digit and the units digit of n as a and b respectively. So then the product would be ab and the sum would be a plus b. And that should be equal to n itself. So I got that ab plus a plus b is equal to 10a plus b.
Hmm.
And then if you solve that, you get ab is equal to 9a, which gets you b is equal to 9.
B is equal to 9, then what is A then?
I am not sure because it just asks for the units digit. I don't know if there's a specific way to get A. Because even if you tried plugging it in, wouldn't you just get like stuff?
10A plus 9. So basically, any number like this will satisfy this property.
Yeah.
One product is 9, doesn't satisfy all the time. 119 doesn't satisfy it. And it's a
19 does, right? It does.
how
The product is 9 and the sum is 10. 9 plus 10 is 19.
any digit is satisfying.
Yeah.
Okay, so from the solution here, we are getting that there is no restriction on A, but you're getting B is 9. So the units digit is 9, and the tens digit can be anything except 0. A cannot be 0, obviously. Because A cannot be 0, that's why we cancelled off the A. Because if A was 0, it is no longer a 2-digit number.
Mm-hmm.
Have we done 16.5.5?
Yeah.
Okay. How?
So a function f of x comma y of two variables has the property that f of x comma y is equal to x plus f of x minus 1 comma x minus y. If f of 1 comma 0 equals 5, then what is the value of f of 5 comma 2? So what I did, we already know that f of 1 comma 0 is equal to 5. So what I did is that I kind of worked my way through it. So first I tried to find the value of f of 2 comma 2. So if you do that, then you get 2 plus f of 1 comma 0, which we already know is 5. So then you get f of 2 comma 2 is equal to 7. And then I tried to find f of 3 comma 1, which I got 10 by using f of 2 comma 2. And then I got 10 for that. And then I did the same with f of 4 comma 3, which I got 4 plus 10 is equal to 14. And then I finally did the same to f of 5 comma 2, which I got 19.
How are you knowing which ones to take, which function values to take?
Okay, so what I did, so for example, to get 3 comma 1, I wanted to get that f of x minus 1 comma x minus y to a value that I already knew. So to get that x would be equal to 2, in that function, I had to make the x 3, and then the same thing for the y value, I had to make it
You are
1.
saying it in the wrong way. The way you have to start explaining it is you have to start from the end, not from the beginning. The question is asking us for 5 2. When you put 5 2, you will realize you need 5 plus f of 4 comma 5. You need this now.
Yeah.
You understand that you're saying the whole thing the opposite way.
Oh, yeah.
The way you figure out is not by magic. I start with f of 1 comma 0 and then I choose f of 2 comma 2 and then I choose 3 comma 1. There is no pattern to this. It's not like magic, right? How will you get this idea? You understand what I'm saying?
Yeah, I get it. You have to work backwards.
If you are explaining it forwards in a weird way, nobody gets the idea that after 1 comma 0 you should choose 2 comma 2 and then 3 comma 1 and then 4 comma 3 and then you'll get 5 comma 2.
Mm-hmm.
So how come you are saying it like that? You should be saying it in the opposite way. Do you understand?
Yeah, I get what you're saying.
Like nobody is that smart that they know all the steps, which numbers to pick each step from the beginning. When you're doing the problem, you have to do it in the correct way. The correct way is to look at the target and realize that I need 4 comma 3. When you try to find 4 comma 3, you'll realize you need 3 comma 1.
Mm-hmm.
Okay, in review problems, there is one more exercise about some relations and all, which is pretty easy. If there's some defined rules, you have to follow those rules to calculate whatever has to be done. Is there any problem in the 4-5 questions in 16.6?
No.
Okay. Try 16.27, the review problems.
2, 7. Okay. For A, I got 1.
The rest.
And then for B, I got that x should be greater than or equal to 3.5. And then for the range, I got that y should be greater than or equal to -8. Or not y, f of x, f of x.
Okay. While calculating range, what is the logic? Why should it be greater than equal to negative?
Because the thing is, since the root cannot be it cannot be the square root of a negative number if you want range the range is the real output that a function can have. So if the root has a negative number, then it won't be real, it'll be a complex number. So the lowest value that the root can be is 0. So then the minimum value the function can have is -8.
This part, the root can be anything above 0. So
Yeah.
obviously, higher values are possible, but it cannot be less than 0. So lowest value for the overall function is -8. The
Yeah.
domain comes by checking 2x minus 7 is greater than 0.
Mhm.
X is greater than 7 by 2 will be the domain. Range will be greater than f of x will be greater than -8. So that is pretty easy. Then 16.30,
Okay.
saying if f of x is 2 of x and g of x is x plus 1, you have to find the value of g of f of g of f of 1.
I got 7 because I just plugged in like 1 into the fx function, then that into the gx, and so on.
G of 2 is 3, so this part will become 3. F of 3 is 6. And G of 6 is 7.
Yeah.
Final answer should be 7.
Yep.
16.35.
Okay.
Does the function f of x is equal to 3x squared plus 5 have an inverse?
It
And
doesn't have an inverse, right?
why not?
Because then the inverse would have to output two different values because it's a square. So it can either have the positive or the negative.
This is a function where multiple inputs will give the same output, right?
Yeah.
Because for example, at x is equal to -1 and x is equal to +1, f of x is still 8.
Mm-hmm.
So you can say f of -1 is equal to f of 1 is equal to 8, right?
Yeah.
So this type of function is known as a many-to-one function, right?
Yeah.
Have you heard of this term? No.
No, I don't think so.
Basically, that means that multiple inputs have the same output.
Mm-hmm.
So that's why it is called many-to-one.
Okay.
Many inputs are giving one output, right?
Yeah.
Such a function you cannot create an inverse, because inverse usually what it does is takes the g function should have been from here to here, right?
Mm-hmm.
But if I try to do inverse here, your 8 will go to two different outputs, right?
Yeah.
That's not possible because this is not a real function. You cannot have a single input giving two different outputs.
Correct.
Do you understand what I'm saying?
Yeah, I understand.
So the only type of functions which have an inverse are those where it is not many to one. It can be one to one. Has to be one to one functions, right?
Mm-hmm.
If there was no double line here, then inverse would have been possible, right?
Yeah.
Because then you would have said inverse input g of 8 would be 1, where g is the inverse function, right?
Right.
So later we'll see examples of functions which are like that, which technically they cannot have an inverse, but then we modify it a little bit and find an inverse anyway. For example, sin x and cos x functions. We'll discuss that later. 16.37.
37. Okay.
This is an important idea of fixed points. So what are fixed points? Fixed points are those values of x for which f of x is equal to x, right? Those
Yeah.
values of x for which f of x is equal to x. So there could be a fixed point to some function. It is not necessary that all functions have fixed points. It's not required that every function has to have a fixed point. But if there is some x for which f of x equals to x, then it has a fixed point, right?
Okay.
So for example, for f of x is equal to 3x plus 10, what is the fixed point? You would say 3x plus 10 should be equal to x. get 2x is minus 10, so x is minus 5.
Mm-hmm.
You can check for the function f of x is 3x plus 10. If you put x as minus 5, f of x also comes out to be minus 5.
Yeah.
Therefore, x is equal to minus 5 is known as a fixed point,
Oh, okay, I see.
right?
Yep.
So part A is telling us what is f of minus 5 if f of x is 3x plus 10. Now,
It should be
obviously,
minus 5.
we have realized that f of minus 5 is minus 5 only. So every time you do f of minus 5, it's same as minus 5. So no matter how many times you do composite function, it remains the same, right?
Yeah.
Even if you do it 4 times, it will be minus 5. So that's why we are calling it fixed point. No matter how many times you apply the function f to it, the value doesn't change as long as you are at the fixed point, right?
Mm-hmm.
Obviously, if you think about it, and f of x was 3x plus 10, and you had done f of 1, the answer would have been totally different, right?
Yeah.
Because f of 1 would have been 13, f of 13 would have been 49, f of 49 would have been 157. So notice what is different about other points, but what is peculiar about fixed point. At a fixed point, you are staying at the minus 5, right?
Yeah.
It's the same function, but f of minus 5 is always minus 5, so nothing changes. But if it was any other value, you would have gotten totally different answers, right?
Yeah.
Okay. Now part B and part C. G of x is given as a function x square minus c. Find all the fixed points of g of x.
Mm-hmm. So wouldn't x be equal to positive or negative root 6?
You have misunderstood what fixed points are. It's not a root of a function that we are trying to find. What is the definition of a fixed point?
A point where the value of the function is equal to x.
So what is the solution? What is the
Oh, so then it would be x squared minus x minus 6 is equal to 0.
so why are you saying plus or minus root 6?
Oh, okay.
Minus 2 and 3 are the fixed points,
Mm-hmm.
right?
Right.
Similarly, part C,
Mm.
A and B are constants and A is not equal to 1. Find the fixed points of f of x.
So ax plus b would be equal to x. So then ax minus x would be, yeah, negative b.
Basically, the fixed point is coming out to be b by 1 minus a.
Yeah.
That's why they said that a is not equal to 1, because then there is no fixed point.
Oh, okay, yeah.
because this point will not be defined, the denominator is 0.
Yes.
So for a linear function, f of x is ax plus b. This is a standard linear function. The fixed point is the constant term by 1 minus the coefficient of the linear term.
Mm-hmm.
Okay? That property will be useful later.
Oh wait, isn't it negative b over 1 over a? 1 minus a?
Which is negative b by a minus 1. That's why I reversed the sign.
Oh, okay, never mind.
Okay, you have to try the questions now. Try the review and the challenge exercises. Most of the questions in the review section we have sort of seen to not be difficult. Try everything in the challenged exercises. See if
Okay.
you're able to do that. After this we have graphing. After that we have polynomials. Okay. So after we have to do all of these chapters and it's fine. So next class we'll try to finish this chapter. So if you can try everything in the challenge exercises, then we'll be able to finish the chapter in the next class.
Okay.
So try the questions and discuss whatever doubts are there.
All right.
Okay, fine. That's all for now then.
Okay. Thank you. Bye.